Today we are going to discuss about wireless LAN. Okay. Um, we already know that the local area network, okay, which is used for making a communication from one node to another node in client server architecture. Okay, we have a LAN in our lab. We have a LAN. Each and every lab is a one local area network. Okay, all the computers are connected through wired medium to the server. Through server only, all the systems are get connected. Okay, all the systems are communicated with each other. At the same way, uh, in terms of mobile communication, the base for mobility or mobile communication is evolved from the wireless local area network. Okay, how can you build a local area network with the wireless? Okay, with the wireless medium. Yes, if you feel any disturbance or voice is not audible, just remain me, ma. Right. Okay, for that, um, there are the technologies are available. There are standards or IEEE standards are available for wireless local area network. Okay, from this diagram itself, we can knows that there are a mobile client. Either it may be a mobile or your laptop can connected to the local area network through access point. Okay, now this access point only make a communication or connection to the fixed network. Okay, you have a fixed network. This network has a router, and that router it's connected to the server through physical medium, through fixed wire. Okay, and here, same way here also there are some mobiles clients, and the access point is available. Through access point only all the data has been communicated to the network. Okay, what are the standards available, what all the way the medium access can be possible in the wireless LAN, those things only we are going to discuss elaborately in this unit. Okay, there are n number of mobile communication technologies are available. Okay, which is suggested by standardized by IEEE, and we already know that WLAN standard number is 802.11. Okay, in case of a fixed network, IEEE standard is 802.3. Okay, all are comes under the same family. Okay, 802 is the family under which 3 means then it is a Ethernet standard, that is wired medium technology. Okay, 802.3. 802.11 is a wireless standard, wireless network standard. Okay, this is a WLAN 802.11 local wireless network. There are n number of standards are being updated, and it's being released. Okay, the device which follows the IEEE 802.11 standard is called as a Wi-Fi, and the various versions like 802.11a, B, C, okay, and N, Z, and after that AZ, BA, BB. Likewise, there are n number of WLAN standard was evolved, and repeatedly used standard is 802.11a and B. Okay, these two standards only they are using as a base for wireless local area network, and there are other standards also possible for wireless local area network, which is called as WPAN. Okay, wireless personal area network. Its standard number is 802.15. Okay, there are two different variants are possible for this WPAN. Okay, 802.15.1 is called as a Bluetooth, and 802.15.4 comes under Zigbee. Okay, likewise, WPAN are related, WLAN IEEE standards are available, and WMAN related wireless metropolitan area network. Okay, wireless metropolitan area network is also possible, which is simply called as a WiMAX. Okay, uh, this concepts alone we are going to discuss in this unit. Okay, we are going to discuss about WLAN, what are the WLAN infrastructures are available, and the architectures and their protocols, as similar to the previous unit, GSM, GPRS, UMTS architecture protocols and all we discussed the same way for the wireless local area network 802.11, the infrastructure, architecture and protocols and their standard defining informations. Okay, all the physical layer informations we are going to discuss. Okay, we already discussed about this the frequency hopping spectrum. Okay, those related topic only we are going to discuss elaborately in this topic. And in addition to that, the WPAN and WMAN. Okay, that is Bluetooth technology and WiMAX technology and Wi-Fi technology we are going to discuss. Okay, before getting to the deep, just we remember the characteristics of wireless LAN. What are the advantages and the disadvantages? Okay, the main advantages of wireless local area network. Okay, if you have a wireless local area network in your organization or in your home, okay, then what kind of advantages you may have? Okay, the main advantage is flexibility. That is, node can communicate without any restriction. Okay, without any restriction, they can communicate. That is, using a radio waves only, the communication is possible in our mobile communication. Okay, through this radio waves can penetrate walls. Okay, walls, and the sender and the receiver can be placed in anywhere. Okay, your sender and the receiver may be placed in anywhere. For that, it's very flexible to access or communicate among the local area network nodes. And the second thing is the planning. We need not to go for any planning to have wires on your building, on our infrastructure. Okay, there is no need of wire to install or to communicate from one device to another device. For that, there is no the need of any wiring plans for making a network. And design. Okay, the wireless LAN design is very small, and the devices and all, it's a very independent small devices which can be put it in our pocket itself. Okay, we can have our wireless router in our pocket, and through which we can make a the communication from one device to another device within a local area network. For that, the design of a WLAN is also, it's very simple and it can be easily created. And the robustness. Okay, that is, wireless network can survive in disaster situations also. Okay, if any natural disasters or happen, then this wireless local area network can communicate it without any disturbance. Then the cost wise is very cheap. Okay, and adding a additional users to the WLAN will not increase the cost of your WLAN. Okay, likewise there are some advantages are possible, but there are some disadvantages too is possible. Okay, that is the quality of service. It's a very important disadvantage. That is, through wireless local area network, we can achieve only a lower bandwidth of data transmission. Okay, the radio transmission speed is from 1 to 10 megabits per second only is possible, but in case of a wired medium, we can achieve 100 Mbps. Okay, just to compare the data transfer rate. In a wired medium, we can go for 100 Mbps, more than gigabits of data transfer rate is possible, but in the wireless local area network, we can go for maximum of 10 megabits per second user data transfer. And the error rate also, it's higher due to interferences. Okay, there are many number of frequencies, many number of electromagnetic waves are spread over the medium. On behalf of that, there may be a lots of interferences are possible, and the delay rate is also higher, since the extensive error correction and detection mechanism is needed. Okay, the error rates are needed, error rates are higher, and because of that, extensive error correction and detection mechanism need to be incorporated into the WLAN. And the second disadvantage is proprietary solution. Okay, that is due to slow standardization procedure. Many companies have come up with the proprietary solution. Okay, they are they are come up with their own WLAN solutions with the high bit rate, and using some patented coding. They may use their own coding, patented coding for a WLAN, and this additional features only work with the homogeneous environment. Okay, for example, if Infosys organization they wants to may have a WLAN, means then they may come up with their own patenting code. Okay, for their own WLAN. Okay, and it can be used only within their organization. It is a homogeneous. It can be used in a homogeneous environment, and the adapters from the same vendors can be used only by that respective vendors only. Okay, for that it is the mainly meant for many number of proprietary solutions, and most components today it's adheres to the basic standards, as I already told you, IEEE 802.11b and IEEE 802.11a. And the other other disadvantage is restrictions. Okay, all wireless products have comply with the national restrictions. Okay, each and every country have their own national restrictions for you accessing or using frequencies for wireless local area network. Okay, for that there are several government and non-government institutions worldwide regulate this the frequency ranges, and they have to minimize the interferences if more than one frequency ranges are available within a particular region. And the WLANs are limited to low power senders and receivers. Okay, certain license-free frequency bands which are not same throughout the world. Okay, each and every country they may have their own frequency bands for making a wireless LAN communication. And the another thing is safety and security. Okay, safety and security related to radio waves is very important. Okay, if you selected a one radio waves for your WLAN, it should not affect the other high-tech equipments. Okay, like equipment which is available in your in a hospital. Okay, it may communicated through radio waves. Okay, if you are building a WLAN in a hospital, then this wireless radio frequency should not disturb the other equipments. Okay, that is another safety and security measure need to be followed, and special precautions have to be taken to prevent safety towards the wireless frequency hazards. And open radio interface makes eavesdropping. Okay, eavesdropping means okay, anyone can interrupt your data. Okay, for that if any person is getting to your location, then they can access your radio frequency from which eavesdropping is possible. And all standard must offer automatic encryption and privacy mechanism. Okay, for that whatever at WLAN standard it's come up, that should be come up with the its own automatic encryption and privacy mechanism. Okay, that is impossible for proprietary solutions. Likewise, there are many advantages and disadvantages are possible while implementing a wireless LAN in your organization, your place. And the basic transmission technology which is followed in your WLAN is the two transmission technology, that is infrared transmission and radio. Okay, infrared transmission is nowadays is absolute. Okay, but for certain kind of applications, infrared blast technology is followed. Okay, I will tell you the infrared blast enabled mobiles and their functionalities. and most of the WLAN follows the radio transmission technologies. Okay, just you know that there are two kinds of basic transmission technology can be followed in the WLAN. One is infrared transmission and radio transmission. Okay, this is about the infrared light technology. Okay, infrared. If you heard the term infrared means, we just remember that you are a TV remote. It works with the infrared transmission. Okay, for that your infrared lights has been diffused and it's scattered through the wall. It may reflected from the wall and it receiver at the receiver end. Okay, normally this infrared devices is come up with the two diodes. Okay, that is your remote, your infrared enabled remote may have a sender LED, okay, light emitting diode, okay, which is shown in the top. Okay, this diode only it's transmit the data in terms of infrared light, and the receiver, okay, that is your television, which consists of a photodiode. Okay, this photodiode only it's acting as a receiver to receive the data from the remote. Okay, the same kind of mechanism only is followed in all the IR enabled devices. Okay, we have a IR enabled mobile also. Okay, infrared enabled LED, infrared enabled mobiles are possible, which is called as a IR blast. Okay, this IR blaster which is enabled in the mobile can make a infrared communication within the local area network. Okay, okay, for that your Android phone. Okay, this is a IR blaster, the device which can be connected to any Android phone in the audio jack. Okay, we have a audio jack. If your mobile is not a IR enabled mobile, then you can convert your mobile to IR blaster mobile by inserting this equipment, okay, the component into the audio jack. Okay, audio jack of your mobile to make your mobile phone as a infrared and enabled mobile. And if you enable this mobile as infrared means, then you can operate your air conditioner, or you can operate your televisions or whatever infrared enabled devices. Okay, those can be operated through mobile itself. Okay, through this infrared itself, infrared technology, devices can communicate with each other as described in this diagram. Okay, air conditioner, your laptop, okay, telephones, your camera, desktop, all this device can be communicated. Okay, that is the basic technology. Nowadays it's being obsolete. Okay, and the second kind of a transmission followed in a wireless LAN is radio transmission. Okay, before get into this, the infrared rays frequencies are comes under 300 gigahertz to 300 terahertz. Okay, these are all the different frequency spectrums. Okay, 300 EHz. Okay, 30 EHz to 300 EHz, so comes under gamma rays, X-rays, ultraviolet, and this is about the infrared. Infrared is also is used for making a WLAN communication, and your radio waves only it's frequently used communication in a WLAN. Okay, which is ranges from 330 Hz to 3000 gigahertz. Normally, what do you call it? 216, okay, 216 gigahertz range of radio waves only is used for the radio, what do you call, used for WLAN, okay, which is defined in a different standard that we will discuss elaborately. Okay, likewise you have a different frequency signals for making a communication in the WLAN. Okay. Okay. Ultraviolet, X-ray, gamma rays may not be used. The basic technology used for wireless communication is infrared and radio wave. Okay, the standards available for WLAN are, as I already told you, IEEE 802.1, 802.11. That is your Wi-Fi. Okay, and there is another standard, IEEE standard called HyperLAN 1, HyperLAN 2 is available. Okay, HyperLAN 2 is the latest WLAN technology, and WPAN, okay, wide area network, widely used technology for it is Bluetooth. Normally, this IEEE 892.11 it can be defined for both infrared and radio transmission. Okay, this is a standard. It's meant for both infrared communication and as well as the radio transmission. But the HyperLAN and Bluetooth, okay, under WPAN we have a Bluetooth standard. This HyperLAN and Bluetooth standard, it's purely rely on radio transmission. Okay. For that through IEEE 802.11 standard, which defines a standard or specification for both infrared and radio transmissions in the WLAN. Okay, before getting to that, we'll just discuss about the infrastructure is possible in the wireless LAN. Oh, just to forget to discuss about the infrared, just to elaborate about the infrared, then we will go for the architecture. Okay, actually infrared light technology which uses the diffusing mechanism, that is the lights are reflected at walls and it communicated to the respective recipient, okay, respective receiving node. And the infrared light technology which works at the frequency or wavelength of 900 nanometers. Okay, 900 nanometers. And okay, as already told you, sender can be a simple light emitting device, okay, LED, and the receiver is a photo diode. And the main advantage of infrared technology is it's simple and extremely cheap for making a sender and receiver, and which can be easily integrated into all the mobile devices. And it can be easily integrated to port PDAs, okay, packet data access nodes, laptops, and it can be incorporated to notebooks, mobile phones, and it can be embedded with the infrared data association interface. Okay, the infrared enabled devices are embedded with IRDA. IRDA stands for I, capital letter, R small. Okay, R small, and DA, it's a capital letter. IRDA stands for infrared data association interface. Okay, the first version is version 1.0, which is standardized, and it implement a data rates up to 115 kilobits per second. Okay, the maximum data rates in the infrared communication is in the version 1.0 is 115 kilobits per second. And there are some other versions also was released, which is called as IRDA 1.1. Okay, 1.1, which defines the 1.152 and the maximum transfer speed in the 1.1 is 4 megabits per second. Okay, the initial version has data transfer of 115 kilobits per second, and the 1.1 version, IRDA 1.1 version, which defines a 4 megabits per second data transfer rate. And we need not to go for any license for infrared communication. Okay, no license are needed, and electrical devices do not interfere with the infrared data transmission. Okay, that is the main advantage of infrared. Okay, if any light is emitting on the room, means it may not affect the infrared transmission. Okay, but there are some disadvantages also possible for infrared light communication in the WLAN, which is a low bandwidth. Okay, maximum 4 megabits per second of data can be possible in the version IRDA 1.1 for the low bandwidth. and it cannot penetrate walls. Okay, other obstacles. If you have any wall, we cannot operate your mobile by sitting on in another room. Okay, so that it cannot penetrate the walls, and for a good transmission quality and high data rates, the line of sight is needed. Okay, line of sight means you have to directly position your remote or infrared device to the respective receiver. Okay, for the line of sight between the sender and the receiver is needed for the good transmission quality and high data rates. Okay, these are the disadvantages is possible in case of infrared data transmission, and because of that we have to go for radio transmission. And this radio transmission way of setting the WLAN may uses here gigahertz frequency. Okay, that is 2.4 gigahertz. Okay, 2.4 gigahertz, it maybe comes under this particular range. 2.4 gigahertz radio transmissions are being used in the WLAN. Okay, and it is also a license free frequency. Okay, which is defined in the ISM band. ISM stands for industrial and scientific medical. I stands for industrial, scientific and medical band. Okay, for that the organization can make use of 2.4 gigahertz without any license for making a WLAN in the organizations, in their locations. And main advantage of having a radio transmission and in the WLAN is it covers larger areas. Okay, the larger areas can be covered by making a radio waves, but it may not be possible in the infrared. Then it can penetrate walls. Radio waves can penetrate walls, furnitures, and even plants. And additional coverage is gained by reflection. Reflection is also possible, and because of that additional gaining of signals is possible, and does not need line of sight, as we discussed in the disadvantage of infrared. In the radio transmission, line of sight is not required, and a higher transmission rate is possible, that is a maximum of 54 megabits per second, as we in the IRDA. Okay, in the infrared 4 megabits per second data rate alone can be achieved, but in the radio transmission 54 megabits per second radio transmission rate can be achieved. Okay, and because of that we need to go for a radio transmission and a kind of a WLAN infrastructure. And the radio transmission too also have a disadvantages. Okay, the radio transmission can interfere with other senders and the electrical devices. Okay, which destroy the radio data transmissions. Okay, for example, if you have a what do you call oven or any radio emitting devices within within your organization, then which disturb or which interfere your radio transmission signals, and very limited range of license free bands only is available. Okay, license free bands are very limited in the case of radio transmission in 2.6 gigahertz frequency range. Okay. Okay, let us go for infrastructure. Okay, there are two different system architecture are possible for a WLAN. Okay, one is infrastructure based WLAN, another one is ad hoc network. Okay, mobile ad hoc network. In the infrastructure based what do you call IEEE 802.1 system architecture, there are several nodes are called as a STAI. Okay, okay, here we have a wired medium. Okay, this wired medium is connected to the access point. Okay, now all the nodes, all the wireless nodes are connected to your access point, Now all the access points are connected through a wired medium. Okay, that is infrastructure based network. Okay, then in a mobile ad hoc network, each and every mobile devices are communicated. Okay, communicated themselves without any access point. Okay, within a limited region. Okay, through Bluetooth technology or through other Zigbee technology, mobile nodes can communicate to other mobile nodes without any infrastructure. Okay, that is called as a mobile ad hoc network. Likewise, your wireless local area network can be broadly classified into infrastructure based WLAN or ad hoc network. Okay, let us discuss about 802.11 IEEE 802.11 system architecture. Okay, under infrastructure based architecture. Okay, this is about the infrastructure based. Since we have access point, okay, each and every nodes, each and every mobile nodes are called as a what do you called as a stations. Okay, stations that can be numbered from STA1, STA2, STI. Okay, likewise, each and every stations are numbered as STAI, and they can connected to the access point. Okay, access point is nothing but your router or the small antenna which you have defined, which you have it in your organization or in your home. Okay, now this the station and the access point. Okay, the station and the access point which are within the same radio coverage, which is called as a base service set. Okay, BSS. BSS is nothing but, okay, the station along with the access point. Okay, they may use the same radio frequency, and because of that, the device which uses the same frequency comes under one BSS, basic service set. Okay, and this access points are connected to the distribution system. Okay, for the distributed system which connects several BSS. Okay, here we have a BSS1 and BSS2. Okay, likewise there are many number of BSS. Okay, many number of WLAN is possible. Here it is a one particular WLAN. Okay, which follows a one radio frequency, and this is a another WLAN. Okay, which follows a another radio frequency. Okay, now these devices, these two devices, that is STA2 and STA3, may uses the same frequency, same radio frequency to access this access point. Okay, and STA1 alone may uses another frequency to access this access point. Now this two wireless LAN has to be communicated through distribution system. Okay, for the two or more WLANs can connected through the distribution system via access point. Okay, for that distribution system along with the BSS is put together, it is called as ESS. Okay, ESS stands for extended service set. Okay, that is a distribution system connected to several BSS via the access point to form a single network, which is called as a extended service set. And each and every extended service set has assigned with the one unique identifier, which is called as a ESSI. Okay, ESSID is available, through which ESSID only one extended service set can communicate to another extended service set. Okay, in order to make communication between your WLAN and then ESSID only, it's acting as a name of your network through which the different nodes can be communicated. And without knowing this ESSID, it should not be possible to participate in the WLAN. And in the distributed system, it connects to the wireless network via the access point, as we already know. And through this access point, it may also connected to the portal, okay, which forms the internetworking of your local area network. That is wired local area network. That is 802.3. Okay, 802.3 means it is Ethernet, and 802.5 means it is a token ring. Likewise, there are fixed local area network is also possible. Okay, if any wireless local area node wants to communicate to wired local area network, then it can be possible through distributed system. Okay, now this access point, it's transfer the data to the distributed system, and it may access through the portal. Now the portal only in turn transmit the data to the wired medium. Okay, likewise the portal, it's an endpoint which access the wireless data, and it is communicated to wired medium. Okay, and this access point, it supports the roaming. Okay, the roaming is possible. Okay, that is changing of access point. Okay, let us assume that one is station moves from one local area network region to one WLAN region to another WLAN region, means then okay, it may disconnected from the current access point and connected to the another access point. Okay, for the changing of access point is also possible in the access point, and it can be possible through distribution system only. And the access point, it's provide a synchronization process within the BSS, and it supports the power management. Okay, power management under control mechanism and time bounded service. Likewise, there are n number of services are provided by your access point. Okay, we will discuss elaborately all about these things and all. And in case of mobile ad hoc kind of a WLAN, okay, in the IEEE 802.11 system architecture, each and every ad hoc networks doesn't have any specific access point. Okay, it may communicated with themselves, okay, through the ID called as independent BSS. Okay, here station 1, station 2, station 3, okay, they may communicate themselves, okay, either through infrared or through Bluetooth. They can communicate it, and to make one WLAN, and if they may use the same technology to communicate, it means then they may assign with the new ID called as independent BSS. Okay, BSS stands for okay, basic service set. Okay, I stands for independent basic service set, as a number which is assigned for each mobile ad hoc network. Okay, this is another mobile ad hoc network. Okay, IBSS2. Now, yeah, station 1 can communicate to station 2 and station 3. They cannot communicate to station 4 or station 5. Okay, whatever local area network is constructed, okay, this is constructed based upon the distance only. Okay, since a station 1 is far away from station 4, it cannot communicate to station 4. Okay, and it is available in another IBSS. Okay. Likewise, yeah, IEEE 802.11 defines or broadly classified the WLAN network into infrastructure based network and mobile ad hoc network. Okay, let us discuss about the protocol. Okay, IEEE 802.11 WLAN protocol architecture. Okay, if you go through this, this figure shows that the 802.11, that is wireless LAN connected to a fixed switched network. Okay, either it may be 802.3 or 802.5. Okay, token ring fixed network. This communication is connection is possible through access point and the bridge. Okay, bridge, it's a device which interconnects the access point and your fixed network. Okay, actually your uh, each and every component, either it may be a mobile terminal or the access point and your fixed network nodes have their own protocols. Okay, this application layer TCP, IP, and all, it's common in both in wireless network devices as well as wired devices. Okay, then other layers also it's get different. Okay, and as we know that wireless transmission data transfer is lower than the wired medium. Okay, but the application layer doesn't feel about this lower data transfer rate possible in the WLAN. Okay, whatever data is transferred from the wired medium, that should be accessed as it is. Okay, in the wireless devices, but there should be a delay in the data transfer rate in possible in the WLAN, but the application layer should not feel those kind of a delay or error detection, error correction mechanisms in the application layer of wireless devices, such a way that the IEEE 802.11 standard has been defined. Okay, and the standards only, it covers the physical layer. Okay, the 802.11 which defines the detailed specification for only the physical layer and the media access layer. Okay, physical layer and media access layer are specification or standards only is detailedly specified, since these two layers only it's important in the data transmission in the wireless medium. And there are other protocols like a LLC, okay, a logical link control protocols is also available. Okay, as we know that data link layer only is subdivided into two sub layers, like media access control layer and logical link control layer, that you already studied in your network. Okay, but the 802.11 is detailedly describes about the physical layer and the media access control layer. This three layers only is defined in the access point. Okay, physical layer, media access control layer, and LLC layers alone, it's available in the access point in order to make a communication to the 802.3 means Ethernet. Okay, through Ethernet devices. Okay, for that the access point only, it receives the data from mobile devices and it send the data to the wired medium nodes through wire. Okay, because of 802.11 MAC and physical layer and 802.3 MAC and physical layers are available in the access point, and this is about your wired medium device protocols, 802.3 physical and MAC and LLC layers. In all these devices, LLC is common. Okay, let us discuss in detail about this protocols. Actually, your physical layer, okay, this previous, okay, 802.1 physical layer is consists of two sub layers. Okay, it is divided into two sub layer. One is PLCP. PLCP stands for Physical Layer Convergence Protocol. Okay, Physical Layer Convergence Protocol. It actually carries sense signal. Okay, it actually carrier sense signals are possible in the PLCP. This carrier sense signal is also called as a clear channel assessment, CCA. Okay, clear channel assessment. Okay, here it is mentioned clear channel assessment. It is actually a signaling mechanism which is normally used by MAC for indicating the whether the medium is ideal or not. Okay, in order to transmit the data to the medium. Okay, whether a medium is ideal or not has been identified or indicated by this PLCB protocol. Okay, for the physical layer convergence protocol, which has a signaling mechanism, or which has which senses a signaling mechanism, which is called as a clear channel assessment, okay, CCA, which actually indicates the indicates that whether the medium is idle or busy. And it also provides what do you call physical service access point. Okay, physical service access point, which is called as SAP. This SAP service access point, which actually provide a 1 or 2 megabits per second data transfer rate for communicating to the MAC layer. Okay, your physical layer wants to communicate to the data link layer. Okay, for that data communication between the physical and the data link layer itself, there is a data transfer rate is needed, that is provided by your service access point. Okay, 1 to 2 megabits per second data transfer rate can be provided by this physical layer in order to make communication to the MAC layer. Okay, likewise the PLCP sublayer, it provides two important functionalities called as clear channel assessment, which is used for indicating whether the signal is ideal or busy, and the another one is it provides a service access point for our MAC layer. And the second physical layer sublayer is physical medium dependent layer, physical medium dependent protocol. Okay, this physical medium protocol main functionalities are modulation. Okay, that is analog to digital, digital to analog. Modulation process are carried out by this PMD, and encoding and decoding of radio signals. Okay, the encoding and decoding of signals are also carried out by your what do you call the PMD. Okay, physical medium dependent. Okay, in addition to this protocol separation, okay, protocol layers, IEEE 802.11 standard, which also specifies a management layer. Okay, management layer as well as a station management layers also defined. Okay, along with the same PMD, PLCP and MAC layers, it also defines the management layers. Okay, actually this MAC management which actually supports the association and reassociation of a station to an access point. Okay, how the one mobile node is moved from one location to another location, then it has to associate to the current access point. Okay, if it is roamed to another location, then it has to associate it to the current or a new access point. For that association and reassociation of your node can be managed by MAC management layer. Okay, and it also controls the authentication mechanism, encryption, synchronization of a station, and with respect to the access point can be possible, and it also manages the power management. Okay, battery power, how can it need to be managed, okay, to the access point. Okay, that is maintained by this MAC management, and it also maintain a management information base. Okay, MIB is nothing but a library which which is used for maintaining all the mobile nodes, all the nodes informations. Okay, mobile information base is a database which maintains what are all the nodes are connected to this current access points and their related information. And the main task of physical management, okay, PHY management, which is mainly used for making a channel tuning. Okay, each and every nodes has to tune into the current access point radio frequency. For the channel tuning is taken care by your PHY management, and it also has a MAB, that is a physical layer management information base. Okay, it has its own database for maintaining the radio related information and into the WLAN. And finally, station management. Okay, this station management, it actually interacts with the both the management, that is both the physical management and the MAC management, which is mainly responsible for additional higher layer functionalities. Okay, whatever other higher layers or functionalities are available, like controlling of bridge. Okay, there is a bridge device is available in order to make a communication between the access point to what do you call your wired devices. There is a bridge is available. Okay, in order to make a control or in order to transfer your data to the bridge, there is some higher layer functionalities is needed. Those are carried out by the station management. Okay, likewise, the 8.2.11 layer, which defines about the protocol layer and as well as the management layer and the station management layer. Okay, there are two management layers, like a physical management layer and MAC management layers are defined, and put together these two managements are managed by the station management layer. Okay, as I already told you, IEEE 802.11 standard, which defines completely about the physical layer. Okay, physical and MAC layer functionalities only. Okay, the physical layer 802.11 physical layer has three versions. Okay, two radio transmission versions are available, which are working in the range of 2.4 gigahertz radio frequency. Okay, and infrared. One infrared um, radio transmission. Sorry, one infrared based physical layers are possible. Okay, for that, this physical layer, it supports three different physical layer components. One layer is based on the infrared, one layer is based upon the infrared, then another two layers are based on the radio transmission, which may works with the frequency of 2.4 gigahertz. And okay, as we already know that frequency hopping spectrum, it's mechanism which is used for spreading the data into the air. Okay, the frequency hopping spectrum, which may use as a spreading and despreading, and it may transmit the data in the speed of 1 megabits per second. Okay, minimum 2.5 frequency hops can be used in the USA, and two level frequency shift keying. Okay, Gaussian frequency shift keying modulation techniques has been used in the frequency hopping spectrum that we already discussed in the first unit itself. But this FSS may of spreading the data, spreading the frequency mechanism is obsolete. Okay, it's obsolete now. And as I already told you, infrared way of making a data transmission through the medium is also obsolete. Okay, 850 to 950 nano meters light wavelength frequency can be used, and it may diffused by light, and typically 10 meters range. Okay, within a 10-meter range only it can be used, and carrier detection, energy detection, and synchronizations are possible in infrared. And the currently following physical layer protocols is direct sequence spectrum. Okay, that also we discussed in the last session. DSSS. Okay, this modulation, it can make a data transfer rate of 1 megabits per second. It may use a differential binary phase shift keying. Okay, DPPSK shift keying method has been used for data transmission, And there are two types of data can be handled, which consist of preamble and header frame, and the payload. Okay, preamble and header is going to be one part, and a payload is another part. This preamble and header can transmitted with the speed of 1 megabits per second, and the payload alone can be transmitted in the speed of 1 to 2 megabits. Payload is nothing but the user data. Okay, the preamble and header are the datas which is related to control informations. Okay, a frame may consist of preamble and header. I will show you the respective diagram. Yes, this is about the preamble and the header and the payload. Okay, payload is actually a user data part. This user data part can be transmitted in 1 to 2 megabits per second, but the preamble and the header, these two data are transmitted at the speed of 1 megabits per second. Okay, and it may use a Barker code for chipping sequence, that is for encryption and decryption. It may use Unicode. Okay, encoding scheme. Barker code is used, +1 -1. Okay, that you already know. And the maximum radiated power frequency is 1 watts in USA, 100 microwatts in Europe, and minimum 1 milliwatts of radio frequency can be used in DASS. Okay, if you want, I will show you the FHS and DASS concept we discussed in the unit 1.